So let's get to business. Let's talk about that just famous polar vortex that everyone has heard about so much. You know, it's something that is just happening to begin to get into our knowledge. All right, maybe not quite exactly this year per se, but definitely within the last few years. So I remember I was a professor over at Montgomery College, and I was teaching meteorology. And during the, I guess it would be the spring semester of 2014, I remember that there was one of those kind of common around here, maybe for a day or two during the winter, cold snaps, where we had really chilly temperatures, where we couldn't maybe get out of the teens or 20s on a certain day in the winter in terms of Fahrenheit, okay? The thing that was different, though, about the 2014 the kind of cold snap that occurred there is that it seemed like this term came out, the polar vortex, that honestly wasn't really known to anyone, and it seemed like it was a bigger, massive deal, particularly for some reason that year in 2014. And by the way, this map right here actually is apparent temperature. So this is simply sort of real field temperature. So here would be pretty much the wind chill. So when winds blow, you combine that with temperature, there would be such a feel to the air that would be actually feeling colder than the actual temperature would be like. Okay, so that's wind chill. So if you notice in this giant swath of sort of the upper Midwest, even going as far south as towards like the panhandle of Oklahoma, notice all these negative, this is not a misprint at all. These are negative teens, 20s, all the way up here to almost negative 50 and even colder in terms of apparent temperature, okay? And I'll talk about this later. If you go outside in these conditions where wind chill's this cold, you instantly will get frostbite, literally instantly. It's scary, it's very scary. And notice all the way, just even as far south as Texas, wind chills were found to be in the single digits. That's pretty crazy. Go all the way to the tip of Texas, 35-degree wind chill. That's insane for Texas, especially right there towards the southern tip. So going back to the polar vortex essentially becoming a mainstream phrase back in 2014, I did find an article from the Baltimore Sun that did give some serious news about the records that were broken on the date in question, so January 7, 2014, that there's a record low in terms of the high temperature that day. It was only 16 degrees Fahrenheit that day. The low at the time being a record was 3 degrees Fahrenheit. Believe it or not, last year, that record was broken. That already shows you that you get these, these cold snaps that could be a couple days in duration, and typically you see them almost every single winter. They just may be a day or two, right? But it seems like that this whole concept of extreme cold for a couple days in the winter became very popular. So popular that you heard this phrase all over the place, whether it was on the news or in conversations or on having its own Twitter handle. Okay, these are not made up. These are actual tweets that I found doing some research, serious research, on how the polar vortex was sort of used as marketing as well as jokes. Right here, of course, ironically, Frozen, the Disney movie Frozen, came out around that time as well. So of course, AMC theaters jumped right on top of that. I love this one. This just makes so much sense. Maybe you just don't need to go outside. You can just have them shipped to you, these textbooks. And then of course, Jimmy Kimmel, famous late night host, making a cheesy joke, but nonetheless a joke with regards to polar vortex, comparing that really with regards to Mr. Freeze in the Batman movies. Yeah. So anyway, yeah, the polar vortex became really famous then, as if it had never happened before. It basically was a brand new concept, a brand new phenomenon, and everyone was jumping on top of it. I know that doing research on this, there were more actors that were making points about it, like cutesy points, taking pictures of their dogs and cute sweaters and stuff. I mean, it's pretty wild. This, again, serious research I did. Serious research I did for this. And then there was Instagramming of the polar vortex as well. And this actually you can prove that this was from around 2014, because notice this is the Washington Monument. Notice there's some scaffolding on it. This is when that was being repaired, and I believe it was due to the earthquake in 2011 weakening its foundation and causing it to have some cracks and need repairs. So this was actually taken as an Instagram picture. You see the frozen water right here representing the really, really cold conditions, I guess, at that given time. Okay. And this is from Merriam-Webster. So I was doing a search thinking that, oh, maybe the polar vortex became like an actual definition that was printed in like 2014 in the dictionary. Okay, maybe that wasn't true. Yes, the word vortex is a word that's always existed in the dictionary. However, this did give me info that lookups apparently spiked of the vortex on January 6, 2014. Because everyone was so interested in this new phenomenon that was just so cold that it's just, I can't believe it. This never ever happens. Well, it does, and it always has. And it just, sometimes it might be a little more extreme than others. And we'll get into especially this year's episode, which is pretty epic, and we'll talk a bit about that. And then here, this is why it became such a big deal. A blanket of media coverage, and that's essentially, and that would keep you warm during a polar vortex. So I think that helps. I think that helps a lot, okay? I gotta get used to using, I don't usually use these, sorry. There we go. Okay. I like to lump this together, not because it's scientifically really related, but I want to lump it together with the misconceptions that people have as well with the greenhouse effect, okay? So the greenhouse effect is something that I know some people like to use as essentially a reason for global warming. Like they're like, oh, it's because of the greenhouse effect. That's why we have global warming going on. You got to step back a little bit, because just like with the polar vortex always having been in existence, as a matter of fact, the first mention of this term came in the 1850s, and it was in a journal. I didn't look this up. I found it. Noah looked it up for me, luckily, which is good. But yeah, this has been researched and mentioned for centuries, okay? The greenhouse effect does not cause global warming. The greenhouse effect is needed and has always existed on Earth for us to be able to live on it, okay? It's allowing some of the radiation that we absorb at the surface as sunlight, meaning the surface absorbs the sunlight, to basically not all escape space, and to allow for our temperatures to be at a habitable level that we can survive in. Without the greenhouse effect, we would be at a very nippy average temperature on Earth over the whole Earth of 0 degrees Fahrenheit. Pretty brutal. So yeah, we need that greenhouse effect. It's about how climate change certainly can impact, or in other words, not only can the greenhouse effect essentially be enhanced by global warming, okay? Let me just switch that up. Because of increased greenhouse gases, that has been tied to contributing to warming temperatures, okay? So it is connected with global warming, but it isn't the cause of it. In fact, it's been enhanced. That's what I'm trying to get at there. So this may be a little bit confusing. But we can actually also talk about a bit later that the polar vortex actually is tied to its kind of coming down, visiting us more often here in the United States due to climate change. And we'll get more into that. A lot of people are like, oh yeah, polar vortex, yeah, global warming, it's over, that's it. We called it, right? No. In fact, global warming and climate change can justify that there could be more episodes of this polar vortex coming down to affect us. By the way, if anyone has any questions or needs me to just slow down on something, just let me know, okay? Because this is about being able to learn more about some important sort of pieces and concepts. And I like that cartoon. It kind of ties to sort of some of the misconceptions. But we're focusing here on the polar vortex itself. All right, so let's get into the science. And this is, yes, an actual NPR article title. Yeah, they're getting a little, sometimes a little, a little bit sort of outside of the realm of how they usually are. All right, so what is the polar vortex? All right. The polar vortex sits up in the Arctic, really in the poles, okay? And the air that's sitting there is very, very cold, okay? And it's cold due to the lack of solar radiation that gets up in that region. And what's enhanced further, what's going to enhance that further is going to be the ice and the snow that actually is sort of sitting there over the Arctic, okay? Because what that does is it reflects sunlight and lets it go out to space, so that further decreases solar insolation that can exist there. And by the way, half of the year it's dark, and half of the year you have 24 hours of sunlight, but even so, with that 24 hours of sunlight, it's not very intense sunlight. So you do get warmth, relative warmth there, but it's not like you want to go there on a vacation. Yeah. So when we talk about cold air, we're talking here specifically in the upper levels of the atmosphere. And what we mean by the upper levels of the atmosphere is sort of the upper levels of where weather happens. And if I were to draw a quick picture, okay, quick picture here. Here's the surface of Earth. In the top roughly 10 to 12 kilometers above the surface, we have what we call the troposphere. That's the lower layer of the atmosphere. And then just above that is the stratosphere. Okay? We're saying that the polar vortex sits roughly sort of in the upper troposphere, lower stratosphere. And then if we kept going, the span of the atmosphere can keep going way, way, way up here. Okay? Does that make sense? Okay? So we have this cold air, and this cold air up in that area of the atmosphere is going to be associated, it's going to have a low pressure associated with it. Okay? The air temperature in those upper levels can be negative 80 degrees Celsius, not Fahrenheit, Celsius, or colder. So we're talking about some extreme cold. This actually exists on the course of the entire year. However, you end up getting some cycles where it does weaken in the summer and strengthen in the winter, and that's really tied to the sea ice cycle. Okay? So here, this is showing sort of the extent of sea ice sort of sitting there in the Arctic. Okay? And this sea ice becomes a little less intense, certainly, during the warmer months, during the summer, and then when it gets colder in the winter, you would see this build up. Okay? Stay tuned because, as you may have heard, sea ice is generally dwindling down a lot in the Arctic. And in fact, that could be tied to not only this year's episode of the polar vortex, but future episodes to come. And they may be, in fact, more frequent and more intense as well. So just keep that in mind. Are there any questions on that? Okay. I keep pointing up. That's not how it works. There we go. Again, not quite using this often enough. All right, so what happens here is this cold air, if I go back a slide, you see how there's a jet stream surrounding that pocket? The jet stream, there's a polar jet stream, and this jet stream is a current of air in which you have weather systems travel basically on it, okay? When it's really, really cold in the polar vortex, and when you have what we call a zonal jet stream, that's one where you don't have much waviness. It literally will look like kind of a circle that's surrounding that L right here. This is a tight zonal jet stream. This will keep this polar vortex nice and locked up there, and it won't essentially break off or cause any kind of cold episodes further south, right? You tend to see that when the Arctic ice is on its sort of like, higher kilt. However, the fact that in 2018, not only were there the warmest Arctic surface temperatures on record, but also less sea ice than ever. Those two things combined actually caused the jet stream to weaken. The jet stream is really based upon the difference in temperature sort of between the poles and what's kind of south of it. Okay? So when that difference is lessened, there's a lot of calculus and math tied. I don't even remember it. I'm not going to show it. Okay? But when that difference is lessened, okay, that's going to give a jet stream that looks more like what's on the right in this diagram. So you see that this is what we would normally see if we had a stable polar vortex. The cold air sits up in the polar region. The jet stream is strong enough where it doesn't allow it to dip down further south. But if this is going to be a weaker jet stream, notice that that jet stream now has some of these crests and troughs in it. Okay? And those troughs allow the cold air to seep further south. And that's what gives us sort of these fractures and breakoffs of that polar vortex, giving us those brief 1 to 2 day episodes of very cold weather that you may see once or twice normally every single winter, sometimes more intense than others depending on some of those conditions of what's going on up in the Arctic. Okay? So this is what you see. Oh, sure.
Oh, is it really periodic, or is it more random than that?
I would probably call it more, when I say once or twice a winter, we don't know when it's going to happen during the winter. It could happen usually we'd see it in January, February.
I actually meant the waviness.
Oh, well, these kinds of, this could be highly variable in terms of how much waviness there is. If you see it to be such that you may be these crests or even more, higher amplitude and vice versa there. That all can be, random, not random, but it could be variable depending on the conditions that are existing sort of not only in the polar region, but also to the south. Yeah, so it's not a regular, we have it pinpointed to exactly what the jet stream will look like, but the general scope of it is it will be wavier than that. That's when we tend to see those colder episodes, is when you get this waviness to it. Yeah. Are there other questions? Okay. So as I said, the waviness of that jet stream is going to allow the polar vortex to fracture into pieces and then allow it to head southward to dip into the continental U.S., okay, and allow it to sort of extend its influence towards those general areas. Understand that air that's cold and dry, okay, is going to descend, and it's going to descend. And of course, during that descent, as it goes through the lower part of the atmosphere, the stratosphere towards the surface, the air will warm up. So those extreme temperatures I mentioned up in the upper levels, we're not going to feel that, of course. I mean, we would be in deep trouble if that happened. But with that warmth, despite that warmth, you're still going to see, just translated through, we can talk about like the the increase in temperature of that air as it would sink down. I mean, there's general sort of, averages, and, you'd have to kind of pinpoint the amount of moisture in the air, but we don't have to even worry about that. Bottom line is that the air is still going to be really cold when it gets to the surface. It won't be as cold, clearly, as it would be sitting up in the upper levels, but it's going to be much, much colder than you usually would see during a normal winter day wherever you are, okay? So this is what happened, and it's actually happened a few times this winter. And we're going to talk about the specific episode of what happened back in late January. That was a highly publicized situation, especially out in the Midwest U.S. So like places like Chicago, Minneapolis, really had some extremely, extremely cold days, and we'll talk a little bit about that. And by the way, I just also want to point out that there was a secondary sort of episode of this in February, but it just wasn't as extreme as this one was. So we're not going to talk really as much about that one as we will about the one that occurred late January. So this is actually a map of the air temperature that I was able to grab for, in terms of the actual sort of key. I'm guessing that this is sort of the freezing line, I would say. I wish I had a key right here, but notice that, again, you can even see the waviness of this, right? So this actually really ties to that like fracturing and seeping of these cold pockets of air coming from the polar vortex coming really far south. Notice how far south we're getting here. So right down very close to the sort of the southeast US, okay, for that. And then note the wind chills. I think that heat index may have been reserved for that, just that tip of Florida, and maybe for Southern California. Otherwise, you can treat almost all of this as wind chill, being the apparent temperature. So notice, just like that map I showed from like 2014, notice all of this here, negative 30s, negative 40s. And the fact is, wind chills that are negative 25 Fahrenheit or lower will cause frostbite to skin that's exposed in 1 minute, and then, of course, under this, less than that, okay? So extremely large area of the country at that point was experiencing these wind chills that were to the point of extreme danger. And the National Weather Service and NOAA are going to give, of course, these wind advisory or wind chill warnings and such so that people know, yeah, don't take this as a joke. If you go outside and you have any exposed skin, you're going to be in deep trouble. Okay, so that definitely was apparent. I wish I had a map that we can acquire of all the different warnings and watches that were going on for wind chill at the time, and I would bet they probably span this area anyway. So that probably is a good representation. Notice Baltimore. Yeah, like very much single digits, and even just to the north in like Pennsylvania, just look how brutal it was. Negative teens and 20s in wind chill. Just insane, just insane. And of course, the southern expanse really coming all the way down to this line right here, really, riding through Tennessee and Arkansas, Oklahoma, and so on. This is a satellite image grabbed from one of NOAA's satellites, and this actually is the visible satellite. And this visible satellite usually will give you a really good idea of cloud cover. But yeah, this just looks like just a bunch of white swirls all over the place. Not only is it capturing the cloud cover, but it also it's also giving you reflections off of the snowpack that was sitting in sort of over Michigan and the Ohio Valley and then out towards like Illinois and so on. Okay, notice the lake effect snow. So this was I want to say this is Lake Michigan. I think that's Lake Michigan right there. Anyway, you can see the coverage of snow over the lake, and also probably the frozen over part of the lake, which is probably the whole lake. So pretty insane stuff that you can grab from satellite here. Okay. Here's Chicago, Illinois. And this was an actual observation of low temperature on, I believe it was the 30th. So that was 8:51 Central Time. That's an actual temperature, not a wind chill, an actual temperature. Negative 22 degrees Fahrenheit. As a rough low, it was actually negative 23, to have to be exact. I mean, 1 degree, of course, you know. And yeah, Lake Michigan was frozen, and you can see it right here. Note the temperatures over this it's over a week span, from the 25th all the way to the 31st. Notice the balmy teens, and just a hot 34 degrees on the 28th. then 10 degrees, negative 10 low, These were the most brutal days of the polar vortex episode in Chicago. Negative 23 Fahrenheit was a record low for that day. I think the record was broken from 1960 or something like that. And for all of these days, we could actually say, well, especially the last two here, 30 to 40 degrees below normal for the high temperature and low temperature on those days. So again, very brutal cold air that was over Chicago and a lot of sort of the Midwest U.S. So if we have time, actually, you know what? We don't quite have time, so just if we get this PowerPoint out to everyone if you're interested, this actually shows a clip of a fun experiment that some people did sort of, and of course, you know, it was on Twitter and Instagram, of course, where they would take a boiling pot of water, they'd run outside, and they would just throw it up in the air. And if you have seen something like this, that water in its gas and liquid form would instantly become just solid and just go like in a big puff of smoke up in the air. What you're seeing there is literally instant what we call deposition, which is actually phase change from gas to solid without any pause. So if you go online and search for this kind of stuff, or if you get this PowerPoint, that was a clip of that. That's a common little fun thing that people did, you know, because they had to pass the time because, I mean, you know, schools were probably closed during this time. I think this one was actually from near Chicago. All right, Minneapolis. I mean, I'm not going to get, you know, you can see the temperatures. They parallel pretty much what I just talked about with Chicago. But, you know, again, it's just astounding. Negative 25, negative 28, negative 23 Fahrenheit low temperatures for those last 3 days in January. Just insane, just insane. National Reserve is having this graphic about Arctic cold to come. And, you know, yeah. It almost just makes you speechless as to how cold it was. Then we, you know, of course, note the wind chill temperatures. And again, the biggest danger of this kind of situation were really the dangers of wind chill and the exposed skin. If, you know, anything of that nature is going on, that's going to cause really just instant frostbite. So this is a chart showing sort of how if anything below that red line of warning threshold was basically worse than even the minimum standard for a warning for wind chill. And all of that's, almost all that's underneath that line. That's how brutal we had this for a several-day period. It was a 3-day period or so. And these are all locations in both Minnesota and Wisconsin. Eau Claire's in Wisconsin as well. So again, negative 50s, 60s, negative 65-degree wind chills. Yeah, yeah. All right, and then Baltimore. Can't really give it as much of an impressive treatment. Yeah, we had a really cold day at the end of January. It was a record low temperature in terms of the high temperature for the day. It was only 21 Fahrenheit. Okay, I know it doesn't pale in comparison to negative 10 for a high, but it still was pretty darn cold. And a near record low. It actually wasn't even a record that day. I think it missed it by 1 degree. It was a 5-degree Fahrenheit temperature at BWI for the low temperature. What I want to point out here, sort of as the last point before I hand this off to Dan, is look at the first 5 days of February after that. Notice the temperature transition. So we go from 21, 24, 41, 50, all the way up to 74 on February 5th. This is actually not uncommon with the polar vortex. Just as it likes to give us really, really cold, well below normal temperatures, if you go back to when we were looking at the diagram that dealt with what everything looks like when the polar vortex is upon us, everything travels typically from west to east, right? So when this blob of cold, really cold polar vortex air escapes and goes off to the east, what comes behind it is actually a much warmer area of upper level air, okay? And that can actually cause temperatures to swing violently. Like if you go back to Baltimore, temperatures went up 50 plus degrees over 5 or 6 days, 50 degrees Fahrenheit. This was not uncommon in Chicago or Minneapolis. Yeah, it was all relative. Chicago warmed up to 51, maybe not 70, but 51 from negative 10 Fahrenheit just a few days earlier. That's 60-degree difference right there in temperature. Minneapolis, about 50-degree difference, going from negative 13 to a balmy 39. And if you factor wind chills in, and this was something that was definitely stated on a lot of news, 80 plus Fahrenheit degrees warmer of sort of temperature feel in these areas just after a few days, you know, when that polar vortex was impacting things. So that is definitely not common. We've seen swings up and down temperature even around here, and that can be tied to the polar vortex essentially moving away. Because when basically it moves away, then the warmer air can certainly replace it because of the waviness of the jet stream. Does that make sense? Okay. All right, the last thing that I would like to just say is just tying this back earlier to discussing how climate change can have impacts on the polar vortex. Yes, some studies have been done, and there's been some thoughts and theories to it. It certainly can be potentially linked because with the warming Arctic, with less sea ice than ever, that removes some of that cold air cap that you can really put onto the Arctic. And that, in fact, can cause that jet stream to be habitually weaker, okay? And that could, in fact, cause there to be more influences of the polar vortex with those little pockets seeping further south, more so, and maybe giving more severe cold conditions than they usually would, okay? And with general warming of the global temperatures, not only can that be tied to more cold spells, but has been looked at to tie to heat waves, more extreme precipitation, which we've seen a ton of, by the way, in Maryland this year. And Ellicott City has seen 2 extreme precip events in the last 3 years that have caused them to have to rebuild that place, and gosh knows if that may happen again, unfortunately. And of course, the hurricanes, looking at the strength and the frequency of hurricanes in the Atlantic and so on. Obviously, you know, we can say these things, but more research has to be done to make this extremely conclusive. And that's sort of the job of all of the researchers and scientists out there to really be able to really hone in on this. But the dangers and potential definitely are there, and the examination of how global warming and climate change impacts and causes these other impacts sort of down the line, you know, has to be taken seriously. And if, again, if we send this out, this is a link to a NewsHour clip talking about polar vortex and particularly this tie to global warming. So if you want to watch that, certainly you can. And now what I'm going to do is transition this to Dan. So talking about the cold, we've done that now. Now we want to talk about all the storminess that we have seen just simply really here, but typically what we've seen coming all the way from like California eventually to here, and what we've seen consistently over the course of this whole winter. This was actually from Wednesday when we were closed. So yeah, that's my son right there. And he enjoyed the snow that day. That is Joshua Anthony Santarelli. That's right, Dan. Yes. And that just shows to the right the radar image, the much less cute radar image of what was going on. It started to snow. Of course, we had to change over to a mix of ice and all that, and then eventually rain. We've seen this happen every so often. Like we saw it the week before. Early in January, we had like 9 inches of snow. So we've had these habitual episodes of storminess, and they've come all the way from California across the U.S. to us. And there's some justification that it's likely due to La Corriente del Nino. So without further ado, I will allow my colleague Dan to go ahead and take over.
So why is it La Corriente?
We'll talk about that. Okay, so when we talk about El Nino, I remember a few years back where El Nino was the big thing. So big, I mean, look at this. El Nino upheaval. El Nino será catastrófico. That doesn't sound good, okay? Even if you don't know what the language is. Devastating El Nino forecast. Girding for El Nino. $1 billion rains. That really doesn't look good. Although, I did notice it says El Nino could be easy on winter heating bills. Maybe there's another aspect to El Nino. Let's see what is El Nino looms, but it won't be all bad. Okay, but generally speaking, what are we talking about? It's disaster, death, and destruction, pretty much when you think about El Nino. Now, this is to the point where El Nino was part of a Saturday Night Live skit. Okay, we're not going to learn about El Nino from Saturday Night Live or Chris Farley. The thing, though, is once Saturday Night Live puts a skit on, it's become a major part of the overall popular topics. So, yeah, yo soy El Nino, all that good stuff. All right, this is middle January. What's the big thing to note here? The whole state of California, it's either raining or it's snowing. Californians are not used to that, especially Southern California. Those of you who have been to Southern California, all you need is a little bit of rain and all hell breaks loose, like big time. Here, it's the whole state of California. It's either under rain, precipitation, or snow. This is the beginning of February. Oh, look, the whole state of California is under snow or rain. The thing about El Nino is that El Nino is not a storm, it's a pattern, but this is looking like an unusual pattern. Here's just a few days ago, hey, look at California. It's under all snow and precipitation, and actually, here's us, okay, during our little winter thing. And because of all this precipitation that's been hitting the West Coast, even up by Seattle, was it last week or a couple of weeks ago, they declared a major emergency because they had never gotten so much snowfall before. And so this is a typical textbook El Nino pattern. All this stuff hitting the West Coast, and then depending on the weather patterns, what happens as it moves across the United States and then hits our area. Have you noticed that we're always in the middle? We're always between that rain and snow and ice line. We always happen to be there for some strange reason. So anyway, this is what got me to really thinking about that, the whole El Nino thing. All right, so what we're going to do is we're going to look at the tropical part of our world, and the light blue areas, the light blue arrows, those are the big picture wind patterns throughout our Earth. This is based on very ideal conditions, no continents, all oceans, and it's very orderly. All I want you to notice is here along the tropical regions, notice that the winds, these trade winds, they're blowing from the east towards the west. Okay, so that's what we're going to focus on. Now this is an ideal world. Let's go ahead and now let's look at the coast of Peru and Ecuador. Generally, we have good fishing in this region. So let's take a look. Here are those tropical trade winds. So what the tropical trade winds are doing, they're blowing the ocean water beneath it, and they're causing the formation of currents. Currents are different from waves. Waves, you know, you guys seen waves before? You know, they do this. The ocean currents, it's the actual movement of the water particles. So you have an ocean current that is being moved in this direction. That would be the equatorial current. Well, water is leaving the coast. Something has to replace it. So it would make sense. You get water coming from the north, water coming from the south. So you have the California current, you have this Peru current. It also comes from somewhere else. So if we look at a three-dimensional look, let's look at it from the vertical extent. So here's a cross-section view of our tropical Pacific Ocean. Here's South America, here's Asia and Australia. This is our Pacific Ocean. Keep in mind that it's on the order of 10,000 miles. It's halfway around the world. It's a big ocean. It's our largest ocean, okay? So here are those trade winds. What happens to the ocean? We have our equatorial current. Okay? So we now have the water moving from South America over towards Asia. When it reaches Asia and Australia, the water downwells. This water in the Western Pacific, that is the warmest open ocean water in the world. Very, very warm temperatures. It took all this time. It's 10,000 mile travel, so it takes more than a couple of days to get there. It takes a while to get there, so that water is really warming up a lot. Here in South America, what we have is now we have upwelling. You kind of get the idea that as you go deeper into the ocean, it gets colder. So you get cold water coming up to the surface, and it would kind of cool this water a bit. On the other end, too, it's where a lot of the nutrients reside. So a lot of the nutrients are deeper, and this upwelling not only brings cooler water to the surface, but it also brings nutrients up to the surface. So think about that. You have surface, sunlight, nutrients, okay? That's where we can get more biological productivity there. In the atmosphere, what you get is, here are the trade winds. Winds will generally blow from high pressure to low pressure. Does that make sense? High pressure, you get a lot of air molecules here. Low pressure, not so many air molecules. So those air molecules want to travel in that direction. It's called wind. So we have our trade winds, high pressure, low pressure. Generally speaking, when you look at the surface maps and you see L's, it stands for low pressure. That often means cloudy conditions, and if the conditions are just right, you get precipitation. When you see the H's or the high pressure, you have generally sinking air, and those are generally fair conditions. That's why we have rainy here and sunny, at least during the day. So let's go back to the fishermen. Every few years, it would be like every 3 to 7 years or so, the fishing would get really bad. When I say really bad, it's like they normally catch 100 fish a day. And it's not like, well, okay, well, today we only caught 80 fish. It's like, well, we only caught 5 fish. So it was very noticeable to the fishermen. They would notice that it would happen around Christmas time, or in the general timeline of about Christmas. The fishermen did note, though, that the water was a little bit warmer than normal. So they gave it a name. Okay, so they gave it this name. Okay, I remember when I started getting into all of this, and then I went to Professor Israel, who is fluent in Spanish, and I said, oh, I'm going to be talking about this El Nino thing, and I said, oh, it's this Corriente del Nino. And she goes, you might want to learn how to pronounce this correctly, because there might be somebody in your class that knows Spanish. So she spent a month with me perfecting my pronunciation. Now, I have to say, it was 1 week of del Nino, but it was 3 weeks of this word. The big thing is that it has a double R. You gotta see, my last name is Spanish, but I don't have a double R in it, so I never had to roll my R. So it's 3 weeks of trying to roll my R's. That was the hard part. Yeah, very difficult. So anyway, it was named La Corriente del Nino. This is not, corriente, by the way, is current. El Nino is the boy. It's not the current of the boy, okay? It's not a literal translation. Because it happens around Christmas time, this is the warm ocean current that happens around Christmas time that drives away all the fish. But it would be kind of long. But it's not a literal translation. A lot of times you'll hear that literal translation. Because many people, like myself, had trouble with that double R thing, it was obviously shortened to simply El Nino. Okay. How did I do? It's okay?
Pretty good, Dan. I know those 2 weeks.
Okay, so let's look at another cross-section view of our Pacific Ocean. If you remember, this used to be a high, this used to be a low. Well, for the most extreme case, and this is the simplest case, they switched. That's called the Southern Oscillation. So it was given a name, Southern Oscillation. Well, remember I said winds blow from high pressure to low pressure? So what we have is we have the reversal of the winds. So now the winds are blowing from Asia and Australia to South America. The water also follows. Notice what happened here. We lost the downwelling. Now do you see why the fishermen noticed that there was warmer water when they lost the fish? Two reasons. All this warm West Pacific Ocean water makes its way towards South America. The other thing is that that upwelling of cold water has stopped. Not only that, but now you don't have the upwelling of the nutrients to go up to the surface. So that affects. So this is the most extreme case. It's a little bit more complicated than this, but this is the most extreme case.
How deep in the ocean does this circulation effect occur? Does it go all the way down to the floor?
Oh, the overall circulation. A lot of these maps, what you're going to see is how it's something called the thermocline. It's how the thermocline moves. The thermocline is actually that depth of the ocean where you go from warm to cold. So if you're looking at a temperature profile, you go from relatively constant temperature, and then all of a sudden it gets real cold. By the time you get to a certain depth, it's just cold all the way. And what ends up happening with this is that thermocline, it gets shoved deeper when you're in this phase, okay? All right, so this is high. It used to be a low. Extreme situation. They're used to cloudy, more moist weather. Extreme cases, drought. This was a high, more fair weather, now more precipitation. Extreme cases, what do we have? California. All that stuff that California was going through. Lots of flooding, okay? Not only that, but like in South America, lots of flooding, lots of standing water. Lots of mosquitoes. Lots of mosquitoes, more malaria, more disease.
Lots of crops as well. They have a lot of potatoes, all of their farms getting.
Let me go into the other part of this. So what we end up with is, for the extreme cases, you can see where this southern oscillation can cause drought cases and lots of flooding, okay? Now, this same El Nino is often referred to as años de abundancia. That kind of sounds good. Años de abundancia, abundancia, yeah, it's abundance, years of abundance, or the abundant times. And what you have in this case is a situation where it's not the fishermen that are talking about the abundant times. Who's talking about the abundant times? So in this case, the abundant times of the farms, a lot more precipitation. What I'm trying to get here is that El Nino, it causes things to happen. It doesn't cause bad things. It causes things. We're the ones that have that value system. So it depends on, if we get less snow during the winter, is that a good thing or a bad thing? If you're a skier, it's not a good thing. Okay, if you don't like snow. So it causes things to happen. It doesn't cause bad things to happen only. The atmospheric part has to do with a southern oscillation. Scientists chose two locations, Darwin, Australia, and Tahiti, and the air pressure is monitored between Darwin and Tahiti. That air pressure difference is given a name. It's called the Southern Oscillation Index. But the Southern Oscillation is that atmospheric part. Again, the high pressure and low pressure. The index is an actual measure. It's an attached number to this seesawing effect with the air pressure. And if you can take a look here, here is from 1970 to about 2000. This is the ocean temperature departures, or what ocean temperatures on average are doing compared to normal temperatures. Notice these big red spikes. Those are El Nino situations. A big one was back in 1982, 1983. There was another one around 1996. Notice that on this other end, this is the Southern Oscillation Index, where you have these regions of high temperature deviations. You have a negative Southern Oscillation Index, and you kind of see that they sort of take on sort of mirror effects. And so the way I look at it, El Nino is the oceanographic part, because the fishermen named it. Southern Oscillation would be the atmospheric part, because it has to do with the atmospherics changing. And then so if you put it together, you have the El Nino Southern Oscillation. That's the whole coupling of the atmosphere and the ocean. All right. Generally speaking, what you have is you have El Nino, and then afterwards, maybe after a year, it returns to normal. So it goes into the normal or regular or the neutral phase. Every once in a while, scientists found out, it gets colder than normal off the coast of Peru and Ecuador. It gets really cold. So the scientists kind of studied it, kept on looking at it a little bit more, and then what they noticed was, it has its own set of effects. This is significant enough that we got to study it, and we have to address this phenomenon. Since it's colder than normal, they said, oh, well, the warmer than normal is the El Nino, so we'll call this the anti-El Nino. What ended up happening was the scientists found out, man, this is a really big mistake. We can't call it anti-El Nino. You remember the whole literal translation thing? That what happened was a lot of people, they sort of understood that El Nino came from the naming of the ocean current because it came around Christmas time, so the El Nino was actually the baby Jesus. When they heard scientists go, oh, we show some evidence where we might see an arrival of an anti-El Nino. What people heard was, the Antichrist is coming. So they said, we can't use this title. So they said, I wonder what El Nino, let's call it El Viejo, the old guy, the boy, the old guy. Sometimes that's used. And then the one that's obviously the most popular is La Nina, El Nino, La Nina. This is the one that has pretty much stuck. Finally, it got to the point where it's kind of El Nino, La Nina, La Corriente, trying to roll your R's. So El Nino, we call that the warm episode or the warm phase. Does that make sense? Warm. La Nina would be the cold episode or the cold phase. And then the third one would be the neutral. Okay, so those would be the main parts. Here's a practical look at a satellite image. This is across the tropical Pacific Ocean. Here's South America. You can see Central America. Same thing here. This is February of 98, February of 99. This is sea surface temperature deviation. Okay, so sea surface temperature anomaly. Again, it's how temperatures differ from the normal temperatures. Red colors are warmer than normal. Blue colors are colder than normal. These two satellite images, this is chlorophyll concentration. It's kind of amazing how you can actually, from satellites hundreds of miles up, you can actually sense chlorophyll concentration to a pretty good extent. This is not anomaly, but actual absolute chlorophyll concentrations. Basically, if you have blue, very low chlorophyll concentrations, once you start getting to light green and yellow, high chlorophyll concentrations. Okay, so given that this is what it looked like, sea surface temperature anomaly, chlorophyll, sea surface temperature anomaly, chlorophyll. One was an El Nino season and one was a La Nina. Which was the El Nino? This is the easy one. Look at that tongue of relatively warm water. Remember, it's not temperature, it's temperature deviation. So because it's the anomaly, you can really see that tongue. Notice that you see some colder than normal temperatures. It's not as distinct as El Nino, which is why El Nino was kind of discovered and focused on first. Why do you have so much more yellow during the La Nina condition? Here's El Nino, here's the La Nina. Why do you show so much more chlorophyll? Yeah, basically what happens here is, especially after a strong El Nino, it seesaws to the other extent, to the colder than normal temperatures. So the winds increase, greater upwelling of colder water, along with the extra colder water, you get the extra nutrients. So that's why you have more chlorophyll. Okay? All right, this is January. This is the sea surface temperature anomaly across the equator. And from this legend, you can see that the browns are warmer than normal. Do you see an El Nino signature? Okay, across the equator, warmer than normal. This is an El Nino signature. In January, everybody was watching this carefully. However, it was not deemed yet to be an El Nino because the atmosphere didn't couple with it. The atmosphere hadn't gotten there yet. So remember the Southern Oscillation Index? Basically, a southern oscillation index of negative value, that tells you that that looks like an El Nino is occurring. So it was on the 14th of this month that the El Nino was deemed official by NOAA, National Oceanic and Atmospheric Administration. As a matter of fact, the specific organization with the NOAA was the Climate Prediction Center that looks at that. And isn't that where Allison works? It's in Greenbelt, Climate Prediction. Oh, College Park. Isn't there that where
Climate Prediction Center is in the same building as one of them.
It's the same. Okay, yeah. So anyway, they take a look at that and notice that in the middle of February, look what happened to the Southern Oscillation Index. It finally went down to negative, which now gives it the signature for El Nino conditions. Okay, so different effects of El Nino. They're global. Some of the things that happen worldwide, we talked about El Nino dry weather, dry conditions over by Australia and a lot of the regions in India and also in Asia. Heavy rains off the coast of Africa. La Nina, colder than normal. Now you have heavy rains along these regions and droughts off the coast of Africa. Another thing is that during El Nino seasons, our Atlantic hurricane seasons are significantly milder. You can expect that. So is that a good thing or a bad thing? Well, if you're from Florida, you don't want a bunch of hurricanes. But again, it depends. Some locations actually need that extra rain from the residual storms from tropical systems. That could be a bad thing. So overall summary, the polar vortex, it's not just a social buzz phrase. When was that? It kind of got big 2014 for some, but it's always been there. It's a real phenomenon. It's always there. It's in the Arctic, and it's actually when it weakens that those effects get to us, and all of a sudden somebody brings back, oh, a polar vortex. Polar vortex is here. You can get very frigid conditions. It was particularly noticeable this year. Not only the frigid conditions, but what? The extra warm conditions. And we're going to take a look and keep on studying, see how how global warming is influencing the polar vortex. As far as La Corriente del Nino, okay, it's a coupled ocean and atmospheric event. It does have global ramifications. It's not just there for the fishermen off the coast of Peru and Ecuador. There are different degrees of El Nino intensities, and different effects will vary. So not all the same things will happen just because we have an El Nino. There are differences. La Nina will sometimes occur after an El Nino event. Oftentimes, if it's a really strong El Nino event, that's when we have a La Nina. Studies continue to be done. They do look at other oscillation type things in the Atlantic, also the Indian Ocean, but by far the most dramatic is found across the tropical Pacific Ocean. And El Nino does not only cause bad things to happen. There are actually good things that occur. Okay. Now, after all is said and done, I showed you all that rain in California, the whole pattern. As it turns out, many meteorologists have realized that wasn't caused by El Nino. That was caused by a different kind of oscillation called the Madden Jr. oscillation, which is a little bit more complex, but it's a shorter duration oscillation. So it was not a direct El Nino thing, especially since this El Nino is deemed to be a mild one. It is by no means one of those really strong El Ninos. Okay?
I want to put one more thing out, actually. If you guys have been in the area for a few years, so the two huge snowstorms that we've experienced, so one in 2010 and one in 2016, you guys recall those? So those are basically historic snowstorms for this area. We got like 2 to 3 feet of snow generally across the DMV area. Those are both El Nino seasons. So the impacts can certainly be felt here where there's a higher potential for the development of those kinds of nor'easter type storms to right up the coast to produce that kind of output. But that all depends on really how much cold air can get in with that instability. So I just wanted to point that last piece out. So.
Yeah, and I had a question, could be for either one of you. I was ENSO, an El Nino summer oscillation, like the middle of February? Doesn't it usually occur like sometime, or
I think
or
that
can
the
it
word
vary a lot?
the word usual with I think the El Nino solar oscillation is one of those words that doesn't quite fit, because I think it really can vary, because like this kind of sort of like change from El Nino to normal to La Nina, they occur every 3 to 7 years, but it's every 3 to 7 years, so it could be anywhere within that that time period. And I think the sync up really just depends on the severity of it. Dan, I don't know if you have other words on that or
Yeah,
not.
a lot of the El Ninos that I'm aware of, the total signature, both in the atmosphere and in the ocean, they actually start occurring maybe around November and December, and they start really seeing that. Like, for example, this one, only half of it showed up. They were already looking at this back in November. They were watching the ocean. The ocean was acting perfect. The atmosphere wasn't yet.
Yeah, that was the part I thought it seemed to happen
Yeah.
much later than it ordinarily would.
Yes, that's why weather is not straightforward.
Yeah, it's definitely not. It's very wavy, like the polar vortex. Yeah.
Yeah, weather forecasters need a very thick skin.
Yeah. If you guys have other questions or yes.
Does the same polar vortex occur at the Antarctica? Does it occur there?
You do have a similar. You also have a polar vortex. The only thing is when you talk about the influences, you don't quite have the same awareness, because there's a lot more ocean in the southern hemisphere.
Yeah, like
there's a lot more, not as much.
Yeah, Antarctica is surrounded by pretty much the Southern Ocean, and then so like the signatures of it are going to be muted quite a bit by them traveling over the water, because the water has a moderating influence, right? So.
But Chile, for example, would see these kinds of vortexes breaking off.
They could. I don't know specifically
Yeah,
about
yeah.
Chilean reports or what they've seen.
Yes, Fabiola, my student. Hi.
I was recently reading a few days ago an article in the Los Angeles Times, and you started talking about how in California they receive precipitation and snow, which is kind of unusual. And I recently read that they're expecting a mega storm of like biblical times where they could receive 10 to 20 feet, and it will rain nonstop for weeks, and it could flood cities, and 1.5 million people have to evacuate possibly within the end of this month and the beginning of March. So I was wondering, is that kind of like what you were showing with like California getting a lot of rain, or is that just something completely different?
What you described is really biblical proportions.
It sounds like a great movie. It sounds like a great movie plot, really. I mean, it's it's Hollywood, right? But no, but I think the area is very right now very prone to getting much more rain and snow depending on the elevation, sort of compared to average. I would say some the summation of all of those kinds of events. I don't know if it would approach that realm, but I mean there's definitely a much higher average than average rainfall and precipitation in that region right now. I mean that much can definitely be said. It's just a matter of it's one of those things with sometimes hype, sometimes the science, and sometimes some of the reality can get a little bit warped depending on what you read.
You better read that article.
But I think I better read that article, yeah. I like to see what they're saying.
Yeah. Is there some explanation for the oscillations? I mean, what causes what's the theory of why I get the change?
Oh, you mean like the southern oscillation part, or that?
What's causing all it? Why do you get the oscillations?
Good
Just
question.
tons of studies, yeah.
Since it's a coupled ocean atmospheric phenomenon, I chose to choose the atmosphere. Something in the atmosphere happens to cause something in the ocean to happen. But it's like the chicken and the egg argument.
Yeah.
Which happens first? Because weather conditions and oceanic conditions, they're basically both fluids. And they're constantly moving. They're constantly being affected by uneven heating of the ocean, of the atmosphere. And because of that, you'll get the changes in pressure. Because of the changes in pressure, you get changes in wind. But what normally happens is there's a tendency to want to go back to some equilibrium. And within that going back to the equilibrium, you get that seesaw. And that seesaw effect ends up being sort of that oscillation. We do find a similar thing in the North Atlantic. Also, we do find one in the Indian Ocean, similar things. We don't quite know as much as far as those different oscillation events.
I could also say that research-wise, for sort of like specifically what's going like with El Nino Southern Oscillation, the research on it actually doesn't go that far back. I'd say that I noticed a lot of it starting like sort of the 80s, 1980s. And actually, I think NOAA had incorporated a buoy system out there. It's called the Tropical Atmosphere Ocean Array or something. It's a TAL array. And with that, they were really beginning to get more and more into the sort of the why El Nino and La Nina happen. And it's just a continually developing, sort of knowledge for sure, even to this very day. So I mean, that was, what, 30 plus years ago at this point. So it's relatively new, like really studying. And I think it's just due to the episodes of it, just like for the polar vortex, they're becoming more and more, seems like kind of known and famous, I guess. And it's sort of like, hey, let's throw money and let's study it. There's definitely major ramifications with all of it, so it's important to take a look at. So, yeah. Are there any other questions or anything?
Thanks a lot. I think we have a
Yeah. Oh, Deborah.
I have a slightly different kind of question.
All right.
Your story about the polar vortex suddenly springing into abundant notice is a lot like the supermoon phenomenon. And I wonder, do we think this is a good thing or do we think this is a bad thing?
I think it's about who who you talk to. I mean, in terms of, it really just is dependent. Like if you're, making money, with, snow at ski resorts, they're going to just be all over it. But I mean, can they actually go outside when the wind chills are negative 60 Fahrenheit all the time? So.
But do we think that kind of media attention is good for science, bad for science,
Ooh, that's a really good question. That's a really good question. I think it's certainly, I think the answer to that's yes and no. I think yes, with respect to getting more people aware of these types of important phenomena that occur in astronomy and atmosphere, ocean. It's just like having the ways to disseminate that have grown so much with all social media and everything, right? I think that is good. I think it's good for people to know about these things. In terms of then you get into a point of glamorizing it, you get into a phase of like, oh, this is just so cool, and you forget about, oh yeah, this could be really bad. Those elements then kind of come into place. So I think it's a double-edged, I don't know if double-edged sword is the right way, but I think there's definitely pluses and minuses. I mean, I don't know how Dan feels, but.
Was a total solar eclipse a bad thing? It brought about an awareness to a lot of people.
That was pretty awesome, yeah.
It's astronomy, right?
But the supermoon is, people get all hyped up about it, and then it's hard to explain, well, this is actually not that unusual.
That means our jobs are that much more important.
That's true, absolutely, very, very well said. All right, well, thank you guys so much for your attention and for coming today.
Enjoy the weekend.
Thank you. Anybody needs to still sign in to the IPD for the faculty or for students, please make sure to do so. Anyone interested in Earth Science Club flyers, I have them right up here. Thanks so much. Thanks so much again.